Session 5, Openstack Compute with Nova. What you will learn in the session is architecture of and components of Nova, managing flavors, managing and accessing an instance using a key pair, launching, shutting down, terminating the instances, managing instance snapshots, managing quotas, getting Nova stats, verifying operations and managing Nova compute servers. Let me put it in a simple terms. You will understand Nova. You will definitely will be working with Nova, but what you will not be doing is you will not be able to practice the examples given this in the lab in the session. Reason being, you need Neutron, you need Cinder in order to launch a server. So I will be able to demonstrate because I already have my entire cloud ready for the demo purpose if required, though I have taken the screenshot. So that depends whether we want to see something in action or not, or we'll wait for your lab. Once you finish the lab, we'll do it together. Let's understand first architecture and components of Nova. OpenStack Compute or Nova service is the heart of OpenStack Cloud. Its main goal is to manage basic virtual machine functions like creating virtual machines, starting virtual machines, stopping, and so on. As with other services, Nova uses a message broker, that is RabbitMQ, which we have configured, message broker, and a database. As usual, by default, the database is MariaDB and message broker is RabbitMQ. The components of Nova, there are a lot of components. One is Nova API service. It accepts and responds to end user compute API calls. Because I have Nova configured on my local machine, so let's look at the services on Ubuntu and whether all the services are running or not. Let's look at them first. Then we'll get into the details of those services in Ubuntu 20.04. This is my controller node and this is my compute node. So we'll look at what all services have been configured on compute and controller. So let's look at the controller node first. Systemctl, grep, Nova. So you see these are the services running on my controller node. Nova API, Nova conductor.service, Nova non-VNC proxy, Nova scheduler. Hypervisor is not running here if you look at carefully, because I'm going to give the same command on my compute node also, and that will show you what all services we have in my compute node. And see that we have a real service running on the compute node, which is Nova compute.service. Actually, this service handles the provisioning and creating and launching the machines. Also, I can say that this is the machine which is working as hypervisor. So I'm not running hypervisor on my controller, and that you can verify on my system. If I show you here also on my dashboard also I can show you where my hypervisor is running. Let me show you on the dashboard. So under system information, admin, compute, and hypervisors, that will show you where the hypervisor is configured and where it is running, and that is visible. If you see here, you will see compute host is only the compute where QEMU type hypervisor is configured, and compute host is nothing but compute where it is configured as I was talking about. So our hypervisor is compute, which is configured on compute host, that is compute in our case. That's precisely I'm trying to explain with these examples. On our compute I configured Nova compute.service, and on controller we have to configure a lot of other services. That includes API service, conductor service, non-VNC proxy, no VNC proxy, and scheduler services. What all these services are, or what these settings are, obviously that's a part of this discussion of the session. Let's get into the details. So Nova API service. What is the role of this service? The role of the service is to accept and respond to end user compute API calls. The service supports the OpenStack compute API. It enforces some policies and initiates most orchestration activities such as running an instance. NOAA scheduler service. It takes a virtual machine instance request from the queue and determines on which compute server host it runs. The selection of hypervisor is based on its weight and filters. Wow! Which essentially means that when you are configuring multiple compute hosts, the way we discussed image storage also, that you can have multiple storage backends and you can give weights to each of the backend which will be used on the weightage and the filters. Similarly, here also we can have multiple hypervisors, multiple compute hosts, and which will be selected, that depends on the weight and the filters which you specify. Filters can include an amount of memory, a requested availability zone, a set of group hosts, among others. The rules apply each time the instance is started or when migrating to another hypervisor. NOAA conductor service. It mediates interactions between NOAA compute service and the database. It eliminates direct accesses to the cloud database made by the NOAA compute service. NOAA conductor modules scale horizontally, meaning you can run it on multiple instances. It can be multiple, it can run on multiple hosts. However, do not deploy it on nodes where NOAA compute service runs. Point to be noted. NOAA compute in our case is running on compute instance, which is separate instance, which I told you that this is my main compute instance where my machines will be located. So don't deploy a NOAA conductor where NOAA compute is running. Otherwise, you can install it anywhere else apart from that. NOAA NoINC proxy daemon, it provides a proxy for accessing running instances through VNC connection. It supports browser-based NoVNC clients, which I have configured, and my instances can be accessed through this URL. NOAA compute. This is the main part of infrastructure as service system, and this is which has been configured on my compute host. This daemon usually runs only on compute nodes, as I said. It should be like this. Its role is to rule hypervisor through hypervisor specific APIs. It is designed to manage pools of computer resources and can work with widely available virtualization technologies, QEMU, KVM, and others. This workflow is very interesting and very important to understand. See, what happens is this is actually the flow, how it works. Instance provisioning workflow. You want to launch an instance, what exactly happens? Step number one, you authenticate yourself through Horizon on the controller node. Then the request goes to Keystone API for authentication. Authenticate and generate token. This is done by Keystone API running on the controller. So you got token that yes, you are a valid user. So after that token is received from the Horizon dashboard, you instantiate or you initiate launch instance. The launch instance request goes to NOAA API running on controller, as we discussed, where the service is running with the token. NOAA API has to validate you. Are you a real user? Are you a genuine region? Is your request valid? Are you allowed to? That token have these permissions, privileges, and authentication details. So therefore, NOAA API running on controller will validate your token from Keystone. So that is step number 3. Validate token and send auth headers with roles and permissions to NOAA API. After this is done, step number 4 will be check NOAA database for conflict and create entry for the new VM. Then you will make a API call. Step number 5, NOAA API will send a request called RPC remote procedure call to NOAA scheduler, which is also running on controller through the message queue. From the queue, Noah scheduler will pick up the request from the message queue because we are using this RabbitMQ, Rabbit message queue. Step number 7, it will find appropriate host through NoahDB via filters and waits if you have multiple compute hosts. Then it sends the RPC call to Noah Compute to launch the instance. So the call goes to Noah Compute. This is running on the host number 2, which is compute node or the hypervisor, and that is compute machine in our case. So Noah Compute will pick up the request from the queue. This is first part. Request has entered into the compute. Before this, all this was happening on the controller node. Then what happens after that is Noah Compute will send RPC call to fetch the instance information, host ID and the flavor from Noah Conductor, which is running on a controller. So Noah Conductor will pick up the request from the queue. Step number 11 will be it interact with Noah DB. It will return the instance information, and then Noah Compute will pick up the instance information from the queue, and then step number 12 will be it pass the token, use image ID to retrieve the image URL from the Glance API. Image metadata, obviously Glance will authenticate, will validate the token from Keystone, and then once token is validated, once your permissions are validated, image metadata is provided, and the step number 14 would be pass auth token, allocate and configure network for VM, which will be handled by Neutron API, which is again running on controller. So Neutron will give you the IP address and network information, which again validate the token before giving the details to you, validate token from Keystone. Finally, step number 16 would be interact with Cinder API to attach volume to the instance so that you can have your instance running. And step number 17 will be generating the data for hypervisor and execute the request via libvirt virtualization library. That's the complete flow, which gives you a role of every component of Noah and the other components in coordination with Noah and Keystone and Glance and Cinder and Neutron, every component which participate when you are launching an instance. So the workflow. In the example, two hosts are used. Compute host, which act as the hypervisor when Noah compute service, where the Noah compute service is running, and controller node with all its management services. The workflow of transferring an instance is the client, in this case Horizon, but it can be Noah CLI also. Ask Keystone API for authentication and generate generate the access token. Step number 2, as given. Step number 2, if authentication succeeds, the client sends a request for a running instance to Noah API. It is similar to Noah boot command. Noah service validates the token and receives headers with roles and permission from the Keystone API that yes, you are a valid user. Then step number 4, Noah checks the database for conflict with existing names of objects and create a new entry for this instance in its database. The Noah API sends the RPC for scheduling instance to Noah scheduler service. Noah scheduler service pick up the request from the message queue. I'm explaining all the steps which I already explained through the figure. Step number 7, Noah scheduler service finds an appropriate compute host through the database via filters and waits. Then scheduler sends the RPC call to Noah compute service to launch the virtual machine. Then step number 8 was Noah compute service pick up the request from message queue. Noah compute service ask Noah conductor to fetch information about the instance, for example host ID, flavors, etc. Then step number 10, Noah conductor service pick up the request from the message queue. Noah conductor service gets information about an instance from the database. Then step number 12, Noah compute takes the instance information from the queue. At this moment, the Noah compute host knows what image will be used to start the instance. Nova Compute asks the Glance API service for the particular image URL. The Glance API validates the token and returns the metadata for the image, including the URL of the image. Then Nova Compute service passes a token to Neutron API and asks it to configure the network for the instance. Neutron will validate the token again and configure the network if it is allowed. Then step number 16, Nova Compute interact with Cinder API to attach the volume which is required for the instance. Then step number 17, Nova Compute generate data for hypervisor and execute the request via libvirt. This is the complete workflow for launching an instance through Nova Compute, and how the request travel from Keystone to Compute. This is the configuration file, that is nova.conf file. If you look at, we have default section where we have IP address, state path, enabled APIs, log directory, transport URL. Transport URL is where we configure the RabbitMQ. Then use Neutron, obviously mandatory, firewall driver. Then API details, auth strategy, API database. Then after that we have object storage name, region 1, that is Cinder storage configuration. Then in the same nova.conf you will find the details about the Neutron, also about the Nova, also about authentication, also you'll find everywhere, like here the database connection, Glance API where the Glance is available, because obviously this has to interact with Glance. Then Keystone auth token, these are all Keystone details. Then virtualization library, and the important part is the Neutron. This is Neutron or networking specific API details where the networking is available. Then similarly placement, which is required mandatory for Nova. There is placement service details including connections. So these are the common. Rest all are VNC enabled is equal to true, or where it will listen what will the IP. So this is a VNC connection settings. So these are important sections. And the quota, default quota, you're asking the instances, RAM, floating IPs, fixed IPs, the default quota which you want to configure on your system. This is actually default quota. You can change this quota, default quota, to something else also. That quota will be visible. So broadly, these are the sections. Let's understand in details. First, IP. This is management interface IP address of the controller node. Use Neutron means enable support for networking service, mandatory. Firewall driver, obviously yes. These configuration settings are for authentication. Authentication parameter, authenticate URI, the public identity API endpoint, and auth URL, admin identity API endpoint. Other parameters meter sets a default project name, domain name, project name for the service, and account information for the Cinder user. Not Cinder user here, we are talking about Nova, not Cinder. So this is Nova username, Nova password. Similarly, API database. This is the database for API. This is database for Nova. This is Nova, Nova API. These are different databases. This is transport URL, which is a RabbitMQ broker address, port, username, and password, which can be configured in the lab number 1 and lab 2. Then VNC details, management interface address for VNC proxy, and the Glance API endpoint, that is Glance API where it is available. So if you look at the main configuration setting, include Neutron, Keystone, Glance, and of course you will find Cinder also. Now working with Nova. Flavor. In Oracle Cloud Infrastructure, we call it as a shape. In AWS, we call it with some other name. But obviously, it refers to the default requirements for, you can say, okay, let me put it in a simple term. It is a template. You create different templates to launch instances. A template consists of RAM, disk, name, properties, swap space, virtual CPUs. So like here, you see the name. So this is name of the shape. In OCI, we call it as a shape. So name of the flavor, RAM, disk, IP address, ephemeral IP address, virtual CPUs is public. So this is shape. Similarly, you can create as many shapes as you want, which actually are nothing but different templates for launching instances. So instance flavor is a template of a virtual machine that describe the main parameters. It's also known as instance type. As I said, in Oracle Cloud Infrastructure, we call it as a shape. And in AWS, we call it as a type. To list the existing flavors, if any, you can use, first you source the credentials and then use OpenStack flavor list. You can also use Nova flavor list, but since it has been integrated and we are deprecating this, it is advisable to use OpenStack for all requests, all commands. To list the details of a flavor, you can use OpenStack flavor show flavor name. Let's look at the flavors in our case. So first what I'll do is I'll source admin OpenRC in my case, OpenStack flavor list. This will show me the list of flavors. And to get the details of the flavor, I'll use flavor show and the flavor ID or the flavor name. Why it is taking time? Finally got the reply. So this is our flavor. Now to get the details about this flavor, I'll use show and the flavor name. This will show me the details of this flavor, the field and the value. So this is the flavor or the shape, or you can say the template details. By default, only admin can list all the flavors and create new ones. Here's an example of creating a new publicly available flavor. Source the file and Nova flavor create or OpenStack flavor create. As I said, it is preferable that you use flavor Nova instead of Nova. You use OpenStack command. OpenStack flavor create is public true. The flavor name auto 402 and 1. What does it mean each of these fields? This will create a flavor with name m10.tiny. This 2 GB of disk. This 400 MB of RAM and 1 CPU. You can delete flavor with the command Nova flavor delete, but I'll say it should be OpenStack flavor delete and the flavor name. Managing an instance using a key pair. Before launching instance, you need to create a key pair. Virtual machines access with OpenSSH key-based authentication is essential for the cloud computing environment. SSH allows you to authenticate users using the private public key pair. Public key is sent to the instance. Private key is retained on the client through which you want to access the remote machine. So in other words, when we will be launching this machine on the cloud, we need to send the public key to the API, to Nova, and we should retain the private key with ourselves. And this private key will be used to connect to the instance later. You should generate two linked cryptographic keys, public and private. Public key can be given to anyone. That's what I am talking about. This is public key sent to the remote instance, and private key should be kept in a secure place. It is only yours. An instance with running the OpenSSH server that has your public key can issue a challenge that can only be answered by the system holding your private key. As a result, it can be authenticated through the presence of your key. This allows you to access a virtual machine in a way that does not require passwords, because that is called key-based authentication. OpenStack can store public keys and put them inside the instance at the moment it is started. It is your responsibility to keep the private key secured. If somebody stole your private key, they can get access to your instances. In GNU Linux, the public keys are stored into .ssh folder in your home directory with the name authorized key files. Let's start creating a key pair. SSH keygen, and you give a name. Basically, this is the no password. We call it as passphrase. No password phrase and quick create. Otherwise, if you don't specify this, it will ask you a lot of questions. So it will quickly create a key and it will be saved. The ID underscore RSA will be the public key and ID underscore RSA will be the private key. So OpenStack key pair create, public key this, and my key. These are the commands. Let's do these commands and let's create the key on our cloud. So I'm first generating the key pair or ssh-keygen quick and no password. So new key will be created, location where it will be created. Oh, it is already there. So overwrite it, no problem. Oh God, I should not have done that. Then OpenStack key pair create. This is the command which will place your key in the Nova. I mean in the cloud. So my key, I'm giving another name, my key one, probably because I already have the keys. So OpenSSH key pair create, public key is located here, my key one, and you can see OpenStack key pair list. That will show you all the key pairs you have. I told you, no, I already have my key. That's why I created with the test one another key. So these are the fingerprints of the keys which are created. These are available in the cloud. The private key is stored in home directory my keys at your workstation. We can use cat my keys. You can check the list of public keys as accessible to you with the command nova key pair list or OpenStack key pair list. You have seen that command, I just demonstrated that. But before SSH client can use a private key, you should make sure that the file has a correct Linux permissions, that is 600, and it's mandatory to have these permissions. You can manage key pair in Horizon also. Go to project, compute and key pairs. So project, compute, key pairs, and here you will find all your keys. You can create and delete, create key pair, import public keys and delete key pairs. When your instance is running and it has a floating IP, you can connect to it with a similar command like ssh-i my keys and the username and the IP address of the instance, where the -i option is for key pair name that points to your private key. Adding rules to security groups. OpenStack security group rule create protocol ICMP default. OpenStack security group rule create protocol TCP. This is ICMP protocol. This is TCP destination port 22 default. So this is how you create security groups to allow incoming connections. We call them as ingress rules and egress rules. Ingress means incoming rules, egress means outgoing rules. Now launching, shutting down and terminating instances. In general, you need at least 4 parameters to start an instance. The name of an instance, the flavor, network and source, that is image. Instance source can be an image, snapshot or block storage volume. At boot time, you can also specify optional parameters like key pair, security group, user data files, and volumes for persistent storage. The general command for launching instance in OpenStack is nova or OpenStack, boot, flavor ID, image ID, key name, user data file, security group name, metadata where key equal to value and key equal to value, so on and so forth, or OpenStack. This is the real command. I don't recommend you use this. I recommend you should use this. OpenStack server create, flavor, image, NIC, net ID, security group, name, and key volume instance, that is key pair details, metadata. And when we say create, no OpenStack server create, this is real example. OpenStack server create, flavor M1 nano, image 0s, NIC, net ID, which I have on my system, security group default, and key name is my keys, the Skillpedia demo. I'll show you everything in action very quickly. I have a script that will launch an instance. Launch instance private net Ubuntu, and this will check everything. This will show you the complete working flow. So checking network connections to compute host, ping command, you are getting the ping, compute ping. So checking service on controller load. I lost the key, that's why it is asking me that. Let me press Control C and use SSH hyphen copy ID controller. That is the problem because I just recreated the key, if you remember, and I should use it for compute also. The new key pair is added. Now I should be able to launch, because otherwise it will ask me. See, now it is not asking. So node controller Neutron L3 agent is up, DHCP agent is up, Neutron metadata is up. All these checking, we are checking the services. Then all services are ready. This is Nova compute. You see everything here. It's checking. The script is verifying each and everything. This is automatic launching of instance through the script. The flavors, then the key pairs. My key is already there. Fingerprint of the key, the rules, available flavors, Neutron, then available networks, then checking the self-service, then DNS entries, then IDs. Private instance is already there, so it is waiting for this to be removed, because my automatic script says that if there is any existing instance, remove it. So launching the new instance now, and it is launched now. It is waiting for the instance to get out of the build state. The instance is active, waiting for DHCP discover. This will give the IP address of the instance, and we will be able to connect to the instance. So this is a complete sequence. So all the sequence, if you my instance, and that you will do in the lab assignment as well, you will verify everything. Once you complete network and Cinder and these, you will see this. Now this is done. Waiting for DHCP success, yes. Now waiting for metadata success, yes. Waiting for login prompt of the instance, it is waiting for that. So the instance will be actually launched, and let's see that instance on the console. So instances, and this is the instance being launched just now with this IPS. The IP address is active right now. Let's go to the console of this instance, console, and it'll show the console of the instance as it is being launched. And you can click here to show you, because of the VNC connection, you can open the instance directly. So this is the instance, and you can see here it is waiting for the login. Private instance login, SirOS. I told you the default username is SirOS, SirOS, and the default password is go, CUBS, go cubes go, and we got that. IP address is assigned, which is 172.16.1.80. So this is the instance which is launched, which got its own private IP. Private IP means within the cloud. It's not public IP. I'll not be able to ping in Google from here. Google will not work. It will not be able to ping. This is private. So that you will see all these examples in the lab assignment you will do when you complete all the services, compute, Neutron, and everything. You have seen quickly in action. Nova OpenStack server list will show you the instance name. You may want to connect to the instance console in a browser by no VNC client, which is VNC client using HTML5 with an encryption support. To get the URL, you can use this command. Nova get VNC console, the instance name no VNC. If you put the URL in the address bar of your browser, you can connect to the machine. The same thing, this is the URL. In similar URL we have seen from the dashboard as well. Launch the instance through the dashboard. If you prefer to work with the instance in GUI, you can use the Horizon web interface. Go to the project, compute, and then instances. So launch instance, and you fill in the details. Details include source, flavor, network, network port, security groups, and star means mandatory, and rest all are optional. So you specify all the details one by one, and then launch the instance. It's self-explanatory. Information about the instances: OpenStack server show instance name, and that will give you the complete information about the instance. Managing instance. If you need to reboot your virtual machine, then you can use OpenStack server reboot. I have not recommended Nova reboot because they are deprecating it, and it might have been already deprecated. OpenStack server reboot, server name. You may stop and start the instance if needed, that is OpenStack server stop. And to delete the instance, OpenStack server delete server name. Managing instance snapshots. OpenStack can create snapshot of instances even if a virtual machine is running. In this case, it is user's obligation to keep the data consistent. It is important to know that snapshot is not an instance recovery point. Snapshot is same as regular glance image. You can start new virtual machine based on the snapshot of another virtual machine. An OpenStack image list. Let's see. Okay, let's power off this instance, and I'll power off this. First, I will shut off this instance, and then I'll create snapshot of this instance. And wow, it got a floating IP address as well. That address, the second address was that was floating IP. Now I can create snapshot. Show me instances. Create snapshot. Snapshot name. Let's say TSP snapshot 1 and create snapshot. So this will create another snapshot. This is as good as an image, and you can launch an instance based on this image. Now you can create snapshot from running instance. OpenStack image create, OpenStack image list. As you can see, snapshot was added to the list in our case. If I try OpenStack image list, you will see similar snapshot. You are free to create a new instance from the snapshot as well. Nova, boot, or OpenStack server create, flavor, image, and snapshot or the new instance name. Managing quotas. A quota limit the number of available resources. The default number of resources allocated or allowed per tenant is defined in the main configuration file. Number of instances allowed per project. You specify this is default value. Number of instance cores allowed per project. Megabytes of RAM allowed per project. Then quota floating IPs, fixed IPs, injected files. Lot of quota settings are there, which you can specify the default quota in nova.conf file. OpenStack Quota Show can be used, or Nova Quota Show. Regular user can get their quota by using Nova Quota Show command. With the command Nova Quota defaults, user can see the default quotas for comparison with their own quotas. Users can see a part of the current quotas in a graphical view on the overview of the project. See here, compute overview, and here you'll see instances 1 of 10, CPU 1 of 20, RAM. So you see everything here, the quota. This is quota coming from nova.conf file. Update quota. Admin can do the same, but for any project with tenant ID option. If an admin needs to change the quota for a particular project, this command would be used. Source the file and quota update. Project name and the quota with the value, which quota you want to change, like instances to 4. And quota show will show you the quota which you have changed. Admin can manage quota per project basis also in the horizon by going to identity projects modify quota and accessing the drop down menu to the right side of the project name. Let's see, identity projects and quota, edit project modify quotas, and here we have the quotas, that is compute quota, volume quota, network quota. What all you can do, you can change. We are admin, so we can change quota for any project. Getting Nova stats, you can use OpenStack hypervisor list. You can check the which instances are running at this particular host, Nova hypervisor servers or OpenStack server list. OpenStack host show, host name can be used. Like here, OpenStack host show compute. So on the compute, what all compute instances are running. To search all running virtual machines, you can use Nova database. OpenStack server list grep active. That will show the active instances. If needed, you can easily get diagnostic information about any instance. That is Nova diagnostic instance ID. At the end, you can get the summary of statistics for each tenant. As admin, you can see an overall picture of hypervisor in horizon also. This is Nova diagnostic, a particular instance, and you see the details. This is hypervisor summary picture under compute, hypervisors, and click on the hypervisor summary, how many vCPUs are used, memory used, and local disk used. Verifying operations and managing Nova compute servers. As I said, we have services that have Nova in them. So you see all the services. If you see Openstack in the beginning, that means this is Red Hat, RHEL or CentOS. If you are using Ubuntu, then it is excluding OpenStack hyphen. So it will be Nova Conductor, Nova Console, Nova Conductor, Nova API, Nova NoVNC proxy, Nova Scheduler. So minus OpenStack. As you can see in this example, many services are running on the same host. In the production environment, all are running on the control nodes except Nova Compute. I told you that Nova Compute should be independent, should be running separately. You can also use Nova Service List for listing the services and the host on which they are running with the status and availability zone. In fact, I will say OpenStack Service List and grep Nova, as we have seen with glance also. Similar command. Now you will find the commands are similar. If you learn one, you learn the other one easily. For troubleshooting, you may need to know where the glance API endpoint is. So OpenStack endpoint list, grep Nova, because we are searching the Nova API endpoint, not glance API. This is wrong. You may also want to check the Nova's log files, which are available under var log Nova directory. With the help of list lsof command, you can enumerate the log files and services that are using it. Test your learning. Which service such as a proxy service between the database and Nova Compute? I leave the answers to you. How can you add new flavor with the name M5 Tiny, 5 GB disk, 2 virtual CPU, and 500 MB RAM? You should do it yourself. I leave it the answer to you. Which Linux permission should be applied to private SSH keys, 600 or 640, or which? Again, I leave the answer to you. Regular user Nova quotas. How can we show them? How can we get summary statistics for all tenants? I leave it to you. These are answers, by the way. And that's all for the session. Thank you very much.